Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guide of notes called Adding and Subtracting Mixed Numbers and sometimes decimals too. Alright, to get started, we're going to talk about when borrowing is needed with subtracting of mixed numbers. Alright, before I even jump into that, let's talk about why am I even subtracting here in my side work? Well, it's because I have a negative and a positive. And when you have a negative plus a positive, two numbers with different signs, you're going to subtract off to the side. Notice I put the bigger absolute value on top. The whole number part is the part that determines who has the bigger absolute value. All right, so with that in mind, I want you to read this information box as I read it to you out loud. Since the numerator of the mixed number up top is bigger than the numerator of the mixed number below, we do not need to borrow here. Here's what I mean. The 9 up here is bigger than the 3 down here. No need to borrow. 9 minus 3 is 6. The whole number is subtracting, pretty easy as well. You're going to get 5. And then since the positive number had the bigger absolute value, the answer stays positive. No big deal. But look over on the right side of your page. This is the other scenario. Again, we have a negative plus a positive, so we're going to subtract off to the side. But this time, read the box. Since the numerator of the mixed number up top is smaller than the numerator of the mixed number below, we do need to borrow. Here's what I mean. The 2 is smaller than the 8. So in order to do the subtraction, we're going to have to borrow. How do I do that? Well, I can borrow from the 7, and that's going to make this become 6. Go ahead and write this down, please, along with me. And then, how do I convert that whole number of 1 that I just borrowed from the 7, how do I convert that to the fraction? Well, I borrowed a whole number of 1, and that is equal to a full 11 out of 11. Now you're like, Underkoffler, why are you picking 11? Because my denominator is 11. If my denominator was 8, then I would have said 8 over 8. If my denominator was 24, then I would have said 24 over 24. So, the one whole that I borrowed from this whole number is now converted to 11 out of 11, and I can add that 11 out of 11 to the 2 out of 11, and that is going to give me 13 out of 11. A shortcut for getting that 13, if I can break out my highlighter here, is to basically take the denominator's value plus the numerator's value, and that will give you the new numerator for any type of borrowing situation. All right, now let's go ahead and subtract. 13 minus 8 is going to give me 5 11ths. 6 minus 2 is going to give me 4. Come back over here. I hope you're writing this down, by the way, along with me. Should this be positive or should it be negative? Well, once again, just like the problem over on the left, here on the right, the positive number is a bigger absolute value than the negative number, so the answer, therefore, will stay positive. Again, go ahead and write that down because that's not written on your paper. Positive 4 and 5 11ths. So once again, conclusion. If the numerator up here is smaller than the numerator down here, you're going to have to borrow. But if the numerator up top is already bigger than the numerator on the bottom, then there's no need to borrow at all. Now, there is an alternate method if you don't want to have to worry about borrowing with mixed numbers ever. An alternate method would be to make them improper fractions. Now, improper fractions is when you have a numerator that is bigger than the denominator. And the way you can get that is by taking the denominator times the whole number part, ignore the negative for now. 11 times 2 is 22. Then add the numerator, plus 8. 22 plus 8 is 30. And then you would throw the negative back on in front. Same thing over here. 11 times 7 is 77, plus 2 is 79. And now, you don't even really need to do side work. A negative plus a positive, you subtract, that gives you 49. Make this now a mixed number, though, because it's an improper fraction. In normally, most real-life situations, we would want the mixed number instead of the improper fraction. So in your head, or maybe off to the side, how many 11s can fit into 49? It'd be 4 of them. 4 times 11 is 44. Subtract, you get 5. The whole number part up here, that's the whole number here. And then the remainder is going to be the numerator. And since it was already over 11 to begin with, it stays over 11. Now, there is a situation where borrowing is never, ever needed, ever. And that's if you're going to add the absolute values of the mixed numbers. Well, when would you do that? Obviously, if you have a positive plus a positive, you would be adding off to the side. And if you have a negative plus a negative, you're going to be adding off to the side. And when you add, never ever have to worry about borrowing. I don't care that the 2 is smaller than 4. I don't care because I'm about to add. 4 plus 2 is 6. 6 plus 5 is 11. Not a big deal. A negative plus a negative stays negative. And there you go. So when you have a negative plus a negative or a positive plus a positive, you're going to add their absolute values off to the side or in your head. No need to do any borrowing whatsoever in that scenario. All right, now, notice the examples that were given above on your paper already had like denominators. You know and I know that if they don't already have like denominators, then you're going to have to do some extra work to rename the fractions so that they do have like denominators. And please do not forget the rules we've been talking about. Negative plus a negative, you're going to add in your head. Answer stays negative. Negative plus a positive, you'll subtract in your head, and the answer will depend on who has the bigger absolute value. Let's take a look at a couple problems that I've started for you. Might not have finished the whole way, though, starting with number 1. Notice the fractions already have like denominators. We got 17 here, 17 here. Yay! Easy math. Oh, but this time, unlike the problems we've been looking at so far on this page, we have subtraction in between. Subtraction is the same as adding the opposite. So that's the very first thing I do. And you can make it adding the opposite right on the original problem. I didn't do that here on my paper because I'm trying to show you that you would take it from here and then make it go here. But you can make it adding the opposite on the original problem. Okay, from here, since we have a positive plus a positive, well, it's kind of like the scenario we were talking about over in the little box side over in the middle of your page on the left. If you have a negative plus a negative or a positive plus a positive, you're never going to have to borrow ever when you're adding the absolute values off to the side or possibly in your head. Might not even need to do side work here. 9 plus 11 would be 20 17ths, and let's add the numerator or the whole number parts. 10 plus 2 will give you 12. Oh, but this problem is unique. After we added, we have an improper fraction inside of a mixed number. So what I'm going to have to do is I'm going to have to think about how do I make this improper fraction not be improper. Well, I put this off to the side for you. Think 20 17ths would be the same as 1 and 3 17ths. So all I would have to do then is add the 1. Let me change highlighter colors here for you. Add the 1 to the 12, and that would make it become 13, and then the 3 17ths. So that's basically how you go from a mixed number that has an improper fraction within it, how you make that a much normal looking simplified improper or a mixed number. Okay, problem number 2. Number 1 already had like denominators, but notice the fractions of number 2 do not have like denominators. 9 and 6, obviously not the same. So in our head or off to the side, we think about multiples of 9. 9, 18, 27, and so on. Multiples of 6, 6, 12, 18, 24. Ah, do you see what I see? The lowest common denominator here would be 18ths. So what I do is underneath the original problem, I'm going to rewrite it with now 18ths as my denominator. But I don't yet know what those numerators are. So I will ask myself, what times 9 gives me 18? Well, that would be 2. And whatever you multiply to the denominator, you're going to multiply to the numerator. Make sure you're writing down this timesing by 2, because I did not already have that for you on your paper. So you're writing this down. 2 times 2, boom, makes this negative 16 and 4 18ths. Please write down that 4 because it is not already on your paper. And then over here, I ask myself, what times 6 is going to make 18? Well, that would be 3. 6 times 3 is 18. And if you do it to the denominator, you're going to also do it up top to the numerator. Again, please write this down. This is not already on your paper. 5 times 3 gives you, boom, 15. All right, What do I do from here? Well, from here I got to pay attention to the signs of the numbers. Notice we have a negative and we have a positive. So I'm going to have to go off to the side and subtract their absolute values. How do I know who goes up top? The mixed number with the bigger absolute value. Look at the whole number part. 16 is bigger than 4, so the 16 goes up top. I do not bring negatives over here in my side work, ever. 16 and 4/18 minus 4 and 15/18. I'm subtracting because it's a negative plus a positive. Do I need to borrow? Stop and think. Is this the kind of subtraction problem where I need to borrow? Well, since the 4 is smaller than 15, yes, I'm going to have to borrow. So let's go ahead and do this together. The 16, I'm going to borrow 1 from it, which now makes it 15. And then I'm going to convert that whole number of 1 to 18/18. And then I'll add that 18/18 to the 4/18. 18 plus 4 is going to give me 22. Now I can go ahead and subtract 22 minus 15 will give me 7/18. 15 minus 4 will give me 11. You're writing this down along with me. Now, will the final answer be positive or will it be negative? Well, who had the bigger absolute value? The negative number did. So it's going to be negative 11 and 7/18. Now, technically, before I circle any final answer, I should ask myself, and I have this in this little box for you in between number 1 and 2, is my answer already in simplest form or can it reduce? Well, 7 is divisible by 7, 18 is not divisible by 7, and 7 is not divisible by anything else, so this is already in simplest form. And back to problem number 1, 3 is divisible by 3 and 1, that's it. Well, 17 is not divisible by 3. If that was 18, then I could reduce the numerator and denominator both by 3. But that's not the case here. So both of these answers were already in simplest form. All right, moving on to the next page. Problems 3, 4, 5, and even 6. Yes, 6 is decimals, but there's a little reminder over here on how you add or subtract decimals. You can read that to yourself. I want you to do these 4 problems on your own. Just 3, 4, 5, and 6. Hit pause now. Do all the work on your own for 3, 4, 5, and 6, and then hit play when you're ready to see how you did. All right, did you already do 3, 4, 5, and 6? If you did not, you need to hit pause now. All right, here I go. Problem number 3. In my head or off to the side, I think about the multiples of 9 and the multiples of 12 because I'm trying to get the lowest common multiple, and that would be 36. So from here, I rewrite the problem with denominators of 36s. My numerators are, at this time, currently blank. Now, I'm eventually going to fill them in. What can I take times 9 to get 36? Well, that would be 4. Sorry, I'm moving the wrong thing. Let me try this again. 9 times 4 would make 36, but then you got to multiply the numerator times 4 as well. 2 times 4 is going to give me 8. Now, what times 12 is 36? That would be 3. So if I multiply the denominator times 3, I got to multiply the numerator times 3 as well, and that's going to give me 21. Will I add in my head or off to the side, or will I subtract? Since it's a negative plus a positive, we are going to have to subtract. Put the bigger absolute value on top, the 16 and 21, 36. Do I need to borrow? Well, no, the 21 is already bigger than 18, so I can go ahead and just subtract. 21 minus 8 is 13. 16 minus 5 is 11. And then I bring it back over here. Will it become positive or will it become negative? Well, it depends on who has the bigger absolute value. And the positive mixed number had the bigger absolute value than the negative mixed number. So that's going to stay a positive 11 and 13, 36. Now, you should have asked yourself if this could reduce. 13 is only divisible by 13 and 1. If this was 26, then yes, I could have reduced them both by 13. But since it's 36, 13 cannot make 36. It can make 39, but it cannot make 36. So this was already in simplest form. Problem number 4. Oh, did you notice there was subtraction in between? The first thing you should have done is made it, boom, adding the opposite, because that's what we do with subtraction. Do they have like denominators? No, they do not. So in my head, I start thinking about multiples of 24 and multiples of 8, and 24 is the lowest common multiple. And the nice thing is, my first fraction was already over 24. So I don't have to change that first fraction at all. But this one I will have to change. What times 8 is going to give me 24? Well, that would be 3. So if I take 8 times 3, I'm going to have to take the 7 times 3 as well, and that's going to give me 21. From here, how do I finish this problem? Well, it's a negative plus a positive, so I'm going to have to subtract their absolute values off to the side. Put the bigger one on top, the 7 and 5/24. Oh, this one I have to borrow because 5 is smaller than 21. So we're going to borrow from 7, make that become 6, and then we're going to have to make this 5 become 24 plus 5, which is 29. From here, I subtract 21 minus 21 is 8. 6 minus 1 is 5. Will this stay positive or will it become negative? This time, the negative mixed number has the bigger absolute value. So that's going to become negative 5 and 8/24. And before you circle that answer, can this reduce? Well, they're evens. Even numbers are always divisible by at least 2, maybe 4, maybe even something bigger like 8. I can divide them both by 8. 8 divided by 8 is 1, and 24 divided by 8 is 3. Negative 5 and 1/3. Now, I hope you guys know, as I go over these problems, if I'm going too fast, if you're like, oh no, I messed up, you can hit pause, fix what you got to fix, and then hit play when you're ready to see the rest of the explanation. Moving on, problem number 5. Subtraction is the same as adding the opposite. That's the very first thing you should have done. Then, in your head or off to the side, think about multiples of 3 and multiples of 4. The lowest common multiple is 12, so you rewrite the problem. Numerators are currently blank. Denominators are now 12. What times 3 is 12? Well, that would be 4. So, if I take this times 4, I'm going to have to take the 2 times 4, and that's going to give me 8. Now, what times 4 is 12? That's going to be 3. So if I take 4 times 3, then I'm going to have to take the 3 times 3, and that's going to become negative 5 and 9/12. This time, I have a negative plus a negative, which means I'm not going to subtract off to the side. I'm going to add off to the side, and maybe you don't even need to do side work if you're adding their absolute values. 8 plus 9 is 17. 2 plus 5 is 7. Bring it back over here. It's going to stay negative. A negative plus a negative stays negative. Oh, this is one of those improper fractions in a mixed number, like problem number 1 on the first page. 17/12 would be 1 and 5/12. Add the 1 to the 7, and that's going to make 8 and 5/12. Throw the negative back on it, and there is your final answer. And then we get number 6. First thing you should do, subtraction is the same as adding the opposite. Now, when you add decimals, you are going to want to do some side work, and you're going to want to line up the decimal points. And to line up the decimal points, you're going to have to make 16.2 written as 16.20, so that way the place values nicely line up, the decimal points are lined up, and now we can go ahead and add. 0 plus 4 is 4. 2 plus 9 is 11, carry that 1. Oops, sorry, spoiler alert. 1 plus 6 is 7, plus 8 is 15, carry that 1. 1 plus 1 is 2, and you're going to get 25.14. In your side work, should the answer stay positive? Well, yeah, it was a positive plus a positive. Answer will definitely stay positive. All right, the last part of the guided notes talks about what do you do when you have to add decimals to fractions or mixed numbers. Should you make the decimals become fractions or mixed numbers, or should you make the fractions and mixed numbers become decimals? Answer, well, it depends. If the fractions would become terminating decimals, now the word terminating means it comes to an end. It actually doesn't go on forever, it stops. Something like 4.25, where it just stops there. That's terminating. If the fractions become terminating decimals, then go ahead and make those fractions become decimals. Make everything in the problem become decimals. That would be quicker and easier to add decimals than it would be to add fractions, because when you add fractions, you have to get common denominators and all that jazz. Adding decimals, pretty easy, as you saw in number 6. You just have to line up the decimal points. But if the fractions would convert to repeating decimals, well, I got news for you. Adding by a decimal that goes on forever, repeats forever, that's kind of a problem. I mean, how would you even do that? So, not a good option. If the fractions convert to repeating decimals, then you're going to want to make everything become fractions. So you'll have to change the decimals into fractions. And after you do that, you're going to want to reduce, however possible, make sure they're simplest form, and then do the work to figure out what the common denominators are, and so on, and so on, and so on. Now, if it sounds like a lot of work to make fractions become decimals, get out the pink paper that I gave you called Common Fraction Decimal Percent Combinations. Everyone should know. Now, I'm assuming that each year that I teach this lesson, that this paper will be pink. Forgive me if one of these years it's not pink. But on this paper are some very common everyday fractions and the decimals that they happen to equal. And you might not have known that thirds, for example, are repeating decimals, or ninths are repeating decimals. Although that one I think I already taught you before. I'll tell you right now, 11ths would be repeating decimals. 6, 1, 6, and 5, 6 are repeating decimals. 7ths are really nasty repeating decimals. And so are things like 13ths and 15ths. So lots of different fractions where you would get repeating decimals. But if it's fourths or halves or fifths or even eighths, those are nice terminating decimals. And that's going to be easier to add by terminating decimals than it would be to add by fractions. Okay, so I want you to follow the advice you were given here. There's 2 more problems at the bottom of the page. Yes, you can look up the decimal equivalents, and if they are terminating decimals, then you're going to want to make everything become decimals before you add or subtract. If they become repeating decimals, then you don't want to go that route, and you're going to have to change the decimal instead into a fraction or mixed number, and then do the work from there. And a little friendly reminder, if there's addition, don't rewrite it as adding the opposite, but if there's subtraction, make that become adding the opposite. This one only had one place that has subtraction. Problem number 8 might have more than just one place that has subtraction. So make each part become adding the opposite. All right, I'm going to stop talking. You're going to hit pause on the video right now and do 7 and 8 on your own. Then you're going to hit play when you're ready to see how you did. All right, did you already do 7 and 8? If not, you need to do them now and hit pause. All right, here we go. 3/4 can become a terminating decimal. 2/5 can become a terminating decimal. So that's what I would do. Make this become negative 2.75. Make negative 8 and 2/5 become negative 8.4. If you looked at your common fractions and their decimal equivalents page, then you easily were able to get that without having to do any additional division work, off to the side. From here, this problem is awesome. You're like, why are you saying it's awesome? It's a negative plus another negative. They're all negative. So you could actually add their absolute values off to the side all at one shot. Now, you're going to have to put some zeros here, so that way you can nicely line up the decimals. 5 plus zeros is 5. 7 plus 7 is 14, plus 4 is 18. You would carry the 1. 1 plus 6 is 7, plus 2 is 9, plus 8 is 17. Keep it negative. Negative 17.85. Problem number 8. 2/3 is a repeating decimal. 5/6 is also a repeating decimal. So we are not going to want to go to the decimal route this time. Instead, we're going to want to make the negative 5.1 become negative 5 1/10. But before I do that, I'm going to make subtraction become adding the opposite there and adding the opposite here. All right, let's make that 5.1 become 5 1/10. And now I got to think about multiples of 3, multiples of 10, multiples of 6, and the lowest common multiple that these 3 denominators could have is 30. So what I do is I rewrite the entire problem with 30ths. 3 times what is 30? That would be 10. So you're going to multiply the numerator times 10 as well. That's going to give you 1 20/30. 10 times what is 30? Well, that would be 3. So I have to multiply the top and bottom by 3. That gives me 5 3/30. And finally, 6 times what is 30? That would be 5. So I'm going to have to multiply the top and bottom by 5. And that's going to give me 25. Well, this problem starts a little bit nice. Positive plus a positive. I can go ahead and add. 1 plus 5 is 6. 23 plus 3 is... Did I say 23? 20 plus 3 is 23. Now I have a positive plus a negative. This is going to require me to subtract off to the side, put the bigger absolute value on top. Oh, nice. I don't have to borrow. 25 is already bigger than 23. So go ahead and subtract. You get 1 2/20. But it's got to be negative because the negative number had the bigger absolute value. And is this in simplest form? I don't think so. They're even. Even numbers are at least divisible by 2. That's going to give you negative 1 1/15. All right, that concludes the guided notes on adding and subtracting mixed numbers and sometimes decimals too. Thank you for watching. We'll see you next time.